Good afternoon and welcome to the CERIAS Security Symposium at Purdue University. Our speaker today is Ron Buskey, Fellow of the Technical Staff for Motorola. And I'm proud to say that Motorola is a member of the CERIAS Industrial Partnership Program. Mr. Buskey heads Motorola's Security Architecture and Research Laboratory. He's been with Motorola for 21 years with a variety of software and systems responsibilities.
Thank you, Joel. Just to kind of a little bit of introduction about who I am and my background so you have some idea of where I'm coming from today. I've been at Motorola 21 years. I spent about 5 years with General Electric before that. Back in the early 80s, I spent a little bit of time with a software startup, kind of before the dot-com craze got really started, but so I've had that experience. Involved in software development, involved with managing software development teams from a few people up to about 50 or so. And also very much involved with the software development process as well as security components. So I've developed software for secure telecom products for the military and government use, so I've been at that level. I have developed software for factory automation, for business systems, finance systems, and been involved with security architecture work in terms of actual product development as well. So I've had a fairly long background over the years of looking at both software development and security architecture feature sets. And what I want to do today is spend just a little bit of time talking through some of my observations about why it's a little bit different looking at what software engineering is and what happens in the security realm, and why sometimes those forces go a little bit different directions and things that you might want to be thinking about. Now, if I hit my target today, what I expect to have happen is a few of the things that I say, each one of you hopefully will say, yes, I've thought about that. That's interesting. You know, why would he bring up that point? But if you only see a few of those points, that means you've been thinking about this kind of a process. Hopefully none of you will sit there and say, well, I've heard all of that before, because that means I'm bringing nothing fresh and new for you to try to think about, so we'll do that. It's my understanding we can be a little bit interactive today, so I welcome questions. Feel free just to stick your hand in the air or yell at me. We'll take it. I will use kind of speaker's prerogative through the course of the day. So if you ask me something and I think it's a little bit more in depth than I want to get into, I will be here for a few minutes after the talk, and I'd love to debate the object after the session. So what I want to do is spend about about 2/3 of my time this afternoon talking about my observations. What is it that's different? What's the tug and pull between security and software? And then I want to end with an example of a program or function that's been recently done within my lab that kind of touches on some of these areas in terms of an embedded system and embedded system development, and about why that's important. I'm only going to just briefly touch on what's going on in that space, but we do have some context, and I'll provide some links at the end of the talk on where you can go to get more information on that. So what I'd like to do is introduce the concept of the environment that I'm dealing with. What is it that I mean when I talk about an embedded device? Because a lot of people today have an opinion or an approach that they think that they mean by an embedded device, but I want to talk about what I mean. So I'm talking about a system that's going to start with 4 processor cores. Now, these are independent processors, typically within the same device. These devices will have at least 5 separate network interfaces. And by separate network interfaces, I mean I'm dealing with a voice circuit call, I'm dealing with an IP data traffic, I may be dealing with a Bluetooth, local area or PAN networks, I may be dealing with things like USB connectivity or time-sliced short message kind of capability. There are 5 separate interfaces. Some of the products we're dealing with may have 2 or 3 more beyond that as well. Typically, I'm talking about at least 2 separate operating systems. Maybe looking at a real-time OS like Vertex or something of that nature. Maybe looking at Linux, Microsoft Mobile, Symbian functions. So typically, these are going to have a mix and match, at least 2, sometimes more, running on these multiple cores. We're talking about a significant amount of memory, in the order of 2, maybe 300 megabytes fixed. The ability to put a gig, maybe 2 gig on these devices from a fixed removable media where I can pull it out and put it into another system. Talking about a device that probably has at least 10 million lines of code. Now this is probably a conservative estimate. The problem is it's very difficult to capture how many things are going into these devices all at the same time. But it's a lot of code, and these are very complex systems. I'm also going to introduce the concept of having 2 separate security models. There's one model that's fairly traditional within the electronics or consumer electronics space, which says that I am protecting the network or the service provider, their services, from the end user. The end user may in fact be the adversary or the attacker in these kind of cases. So what we're seeing is I have services, I have feature sets, I'm delivering this capability into my product, and I'm concerned that the end user who's holding the device in their hand has full access to it and may be able to attack it to get free service or to circumvent functions or to disrupt my network. Now the second security model is pretty much orthogonal to that, and it's the other way around. I'm looking at information that's being presented by the user, owned by the user, and their concern is what's going on from the network. If I have information and connectivity coming in, is someone going to download a virus? Is someone going to give me a Trojan that's going to suck my data out? And in fact, I may not trust the network operator that I'm connected to because they may actually be the attacker, or their system may be subverted by an attacker and be coming after my system. So how do you look at these two specific security models that are very much different, because neither side essentially trusts the other side, and establish a security trust model in the middle? Motorola's been looking at some of those kind of questions, trying to understand who is it that can become that trust agent that both sides can trust to be able to protect their individual stakeholder interest in this kind of device. So what is it that I've been talking about? I'm talking about a cell phone that looks very much like this. This is a fairly recent one. It came out onto the market just in the last couple of months. You may have seen our advertisements for it, but that device has all these characteristics. When I talk about an embedded device, that's what I'm looking at. And a lot of people are not aware that the complexity that goes on inside of that system. So let's take a look a little bit at what is it involved in doing software engineering versus security engineering. So when I talk about people doing software engineering, typically I'm referring to people that are out there that are doing things like defining use cases, looking at requirements capture, defining testability to meet those requirements, developing interfaces, building architectures, and writing software. And they're probably going to go at that in a very iterative process. They're going to write some requirements, they're going to look at some use cases, they're going to build some features, they're going to test it. I can do more. They're going to write some more requirements, some more use cases, and that's going to keep on going. Typically, when I talk to software developers or product developers, they're asking the question, what can I make this device do? What can I do in the market space? Conversely, I'm talking to security engineers, and they're looking at a different set of skills. They're trying to define assets. What's important on the device? Looking at the abuse cases. What can I make this system do badly if I touch it? Probing the interfaces to see, is there weaknesses in the interface itself? Can I extract information? They're looking at cracks in the system. What can I do to get myself in between specific functions? They're doing risk analysis, trying to do trade-off between cost effectiveness and what they're doing, and developing threat models. So if I ask them what their primary job function is what can I make this system do wrong? Now the problem is, if I go into a software development or a product development team and I ask them, who's responsible for doing your security work? The answer I very often get is, oh, Tom and Bob over there kind of think about it on occasion because they've got a little bit of experience and they took a course. Now the problem is that Tom and Bob are doing the things that you see on the left. They're defining use cases, they're writing requirements, they're meeting interfaces, and they're building software. That's what they do, that's what they're paid to do. The problem is that I don't see any overlap between the skills on the right and the skills on the left. So if they're spending all their time thinking in one mode, to ask them to spend a few minutes a day or a couple of hours a week thinking like this other hand, they may do okay because they're really smart people and they're really good at doing things and they're very aggressive at functioning. But guess what? Very good may mean if there's 100 vulnerabilities or 100 open issues within that product, they may find 98. That's okay. Is that good? The problem is that the adversaries that are out there looking at trying to break into these products are still going to have two. And that's not acceptable in most of these cases. So the problem is that we're trying to understand within the problem and domain set that we really need to see the trained professional security engineers that are not spending most of their day developing software, building systems, identifying new product features, but they're looking at these issues from a security standpoint. We have to be able to do this. And that's one of the reasons why we're very much targeting programs like CERIAS here at Purdue, because we believe that they can help train some of these people to bring into our corporate settings and our corporate situations. One of the issues that we have to look at then is the boundary structures. So if I look at a very